All right, folks, let's get started. Good morning, Pierre. Welcome to our weekly episode of the YFTT, the Yugabyte Friday Tech Talks. Every week we pick an area and we go deep down into, how we built it, why we built it, how it works, what doesn't work, what are we going to do in the future. You can tune into us on LinkedIn Live. It's going to be like pretty much this time every Friday. And we have the actual engineers that built the stuff, right? The features, so that you can hear it from the horse's mouth and ask questions and so on and so forth. So it's just supposed to be a live and interactive session, a fun session, just 30 minutes long. Okay, this session is about Collation. And like I have here with me Minghui, the lead engineer who actually built Collation support in YugabyteDB. So I'll get him to introduce himself in a second and we'll get this kicked off. If you folks have questions, you can feel free to just ask in the LinkedIn chat, or you can join our community Slack at yugabyte.com/Slack and go to the YFTT channel, right? And you can holler there as well. So you can get a hold of us in any which way. All right, so with that, Minghui, so maybe let's start with a quick intro about yourself, and then we can go into what's all the stuff about Collation.
Sure, yeah, thank you, Karthik. Hello, everyone. Welcome to the talk. I'm Minghui. I joined Yugabyte a year ago. My career started at Oracle, where I worked on the PL/SQL compiler. So over the years, I have mostly worked on interpreter, language translator, distributed systems. At Yugabyte, I'm working on the query language tier. So it's good to be part of the team.
Awesome. Thanks, Minghui. Okay, so we know that, we all know that collation is a very important thing in databases, right? Because you have different languages, different ways of interpreting the data and the language characters and so on. So maybe, yeah, you can start us out with what is collation really, and just explain it a little bit, and then we can go into.
So let's start with the basics. First, what is collation, right? So collation sounds like a rather geeky word when I first work on this project. But to put it in simple words, a collation is really just a set of rules that define how to compare and sort character strings. So when we talk about comparison and sorting, right? We know database, especially modern database, spend quite some significant time on sorting data, right? So that means get data in the right order is important. But for general data types like integer or timestamp, those data types, people just unanimously agree how they should be sorted, right? So integers, they're totally ordered. So there is no ambiguity there. However, when it comes to character string data types, then things become more complex, right? So for example, the character string have this property, case sensitivity. So when we compare two character strings, should we consider case sensitivity at all, right? Should we ignore case sensitivity? Also, like for some language, they also have accent, and then same question applies there. Should we compare when we compare two strings? Should we ignore case accent or not? Right. So this is essentially collation has to do with string comparison and the order of different strings. So now let's move on to talk about the Postgres collision. So in Postgres collision, it actually means more than sorting and comparison. It is actually a comparison of collate and C type. If you are familiar with the Linux operating system, we know that there are these environment variables, LC collate and LC C type, and there are a bunch of LC variables. But the fact that Postgres implement these two suggests these two are probably the most important. So LC is means locale, which is another geeky word. But collate means it has to do with sorting, and C type it means character type right? So it just says, how characters are classified. So that's why, in Postgres, instead of creating two concepts, they just combine these two into one. So collectively, it's called, Postgres. It's called collation in Postgres. And for example, let's talk about the collation, sorting rule. If you have a lowercase a versus uppercase a, right? Then we ask two questions. First is, are they equal? Right? So this is an equality check. And then in database, the equality check is especially important because it's used to enforce constraint, right? The unique constraint. So if you have a primary key, or if you have a column with a unique constraint, then equality will play an important role here. Right? But then if they are not equal, then the second question is, which one is bigger? Right. So depending on different view, some people compare lowercase a with uppercase a. If you compare their encoding bytes, it can be different from their dictionary order. Right. So this is about the collate. For the C type, it's a little easier. It's just about how characters are classified. Right. So is let's say for the same question, right? Is this letter a lowercase? Right? Or is it a digit? Is it alphanumeric, or is it printable, etc.? So, over time, people have come up with a large set of collation rules, and different collations can impact how characters are sorted or how characters are classified. And in Postgres, this is just a list of typical collations. For example, the first one is the C collation. That's the oldest one, the traditional one. And hopefully everyone use Postgres already knows.
Thanks for making the connect with LC C type and
Yes.
the collation type C. I mean, I never looked up what C meant, but I just thought Postgres was written in C, and so they just put C in. But it's stands for character. That's interesting. Okay.
Right, but the first C collation, it is actually related to programming language C.
Okay, got it.
Yes, that's a good one. So the second is POSIX. It's basically an alias of C. They really internally do the same thing, but then for historical reason, people have two names, two aliases. And then the rest of these are all more modern collations. Like usually when you read the collation name, they're longer. However, they are more descriptive, right? So for example, if you look at ENUS UTF-8, usually a collation will have the language, that's the English. And the second, that will usually have the region, that's the United States, right? The third part is what kind of encoding this collation can work with. So essentially, a collation doesn't work with every possible database encoding. But of course, a C collation can work with any encoding, but in general, this Unicode encodings, that can only work with a limited set of encoding. Collation can only work with a limited set of database encodings. So this leads to what we call collation providers, right? So, we in Yugabyte, we have this architected the software in a way that we reuse the upper half of Postgres implementation, and then we swap out the lower half. Same is true for collation implementation. So we inherit the upper half of the collation implementation from Postgres, right? So we don't define any of these rules. But on the other hand, if you look at how Postgres implement the collation support, it has its own rules, but then mostly it relies on the underlying operating system to provide the support. So like we are two hops to the operating system, but even Postgres doesn't define all of its rules. Like Oracle probably has its own implementation, but Postgres relies on operating system. So in particular, in the operating system, we have two libraries, and then these are considered collation providers. So one is libc, that's I guess since Postgres had a collation concept, then it started using libc first. The second is called the libICU. ICU stands for International Components of Unicode. So basically, it's Unicode library. And then for these two libraries, they are basically form the underpinning of how collisions are supported. And one interesting thing is that libc collation is not platform independent. So basically, we have found that on Mac, libc collation, same name, ENUS, it actually sorts differently from.
Oh my God, okay.
Yeah. So, but that's just a fact. We also inherit, so because of this library difference, you are going to see different behavior if you run YSQL on Mac and Linux. We're going to see that in a demo shortly. To give some perspective.
And libICU doesn't have this issue? libICU sorts the same across both?
Yes. Well, libICU, so far, our internal testing haven't found any difference.
Got it.
So I think because it's ICU library, I think they have this well-known Unicode algorithm. As long as you just implement the same algorithm, you probably get the same sort order. So that's why it's reasonable to believe libICU is a platform independent. And that's also the reason we try to promote ICU collations rather than libc collations.
What's the default? Well, I'm curious. What is the default?
The default is a C collation. So
no, but which provider? Which provider? libc or libc?
It's in C, because the C collation then it's platform independent. Because the implementation is so easy, right? C collation, you just compare the bytes. Yeah. And then as long as the encoding bytes is the same, then the order will be identical.
Got it.
And it's also most efficient. So unless you really need the language-specific order, you probably want to stay with libc. So with the C collation, and C collation comes from libc, right? So we only have 5 libc collations, and then essentially only one more advanced like UTF-8 from libc. That's because most people are familiar with, and the names they are easy to remember. ICU collations names are longer.
Got it. One question, Minghui, from Kurt, which is, are there any important differences between libc and libICU? Right, like maybe just good to recap. So.
Yes. So traditionally, people use libc. However, libc collation, has caused problems. First is whenever you upgrade libc for any reason, right? You might want to upgrade libc for some security patch, and but then if it contains some kind of a collision code change, it can sort of implicitly invalidate all your index that's built on top of the old libc.
That's scary.
Yes, but libICU, and then they care more. It's the ICU, the whole organization is dedicated to this collision. Unlike a libc community, the collision is not their top priority. So ICU organization cares more. So that's why ICU, they actually consider the database application. They are more considerate, so they give you this version number. So they try to preserve your index as much as possible whenever they have some version change.
Got it. Fascinating. Yeah.
Yeah. So let's talk about just the concrete syntax in Postgres. So essentially, as I said, most data types they have unanimous agreement on how things should be ordered. So that's why for most types, they are not collatable. But here, like you just gave an example, is a negative case. We try to create a table. It just has one column ID. It's an integer type. And we try to say, hey, I want this collation. The concrete syntax is collate and give a collation name. Collation name is double quoted. And then here, as we see, the compiler rejected, say, hey, this is not supported by type integer, right? Then that only gives us the text string types that are collatable. So same thing, but then if we have ID as text type, then it is collatable, and then we can see so this is newly enabled in Yugabyte 2.11, release 2.11. So before release 2.11, if you type this statement, you're going to get an error.
Got it. Interesting.
Right.
Yeah.
And here is a simple example. Yeah, let's just see, how exactly this collation can affect the sort order. But here we are talking about still collate, and then it's a simple comparison between lowercase a and uppercase a. Right? So as a left example, we don't have an explicit collation clause, but in fact there is an implicit collation. It's called the default collation. And as we said, default collation is C collation. And then C collation, we just compare their encoding bytes, right? And then YSQL or Yugabyte default, we only support one database encoding, that's UTF-8. And in UTF-8, if you just look up the encoding map, we're going to see like lowercase a is 97 and uppercase a is 65, right? So essentially they're ASCII code. And then that's why this expression is evaluates to false. But on the right-hand side example, then it says, still compare these two, but we have to obey the rule that's specified by this collation, UTF-8 collation. And then according to this collation, they have some code point. Essentially, the code point of lowercase a is a dictionary order. So a comes first. Lowercase a comes first. So we can see the same expression, but if you have a collation clause, then the result actually is different.
Makes sense.
Right. And then, as we said, what's implemented in 2.11 is the thing feature called column collation. Before 2.11, we only support database collation, which is C collation. So essentially, you can't really specify any fancy collations. You can only do byte-wise comparison. But with column collation, then we can create a table, the same table. We create this table. Then we insert two rows into this table. One is lowercase a, the other is uppercase z, right? And then when you do the select, in this case, you don't have to specify the collation because the collation is already attached to the column ID. And then under this collation, it's going to be a dictionary order. So A comes before Z. But imagine if you don't have this collation clause, right? Then when you do this select, you are going to see a Z comes ahead of A, which may seem odd to some people. So next, I'm going to give a demo of how this thing works. I already got things set up, so to save some typing time.
Could we make the font size bigger, Minghui, so it's a little easier to see?
Let's see. Actually, how do I?
Is it if you're on Mac, Apple Plus should do it.
Command plus.
Yeah, Command plus, correct. Yeah.
Okay.
Yeah.
Okay.
Yeah, that's right. That's good. Yeah, that's good. Awesome. So okay, so let's look at what you.
Yeah, let's look at this. I can repeatedly run this, so that's why I dropped the table first and then recreate the table. And we can see where I create a table called a collation demo. Right, it's Spanish, and then we are using a Unicode. This is a Unicode collation. And then after
this
that,
is from LibICU, right? Like, and the extension says it's LibICU. Okay.
Yes. Yeah. Just by seeing ICU, it's actually clear it's coming from the provider is LibICU.
Got it.
Then I do a describe of the table, and as we can see, the table now has the collation specified in this column. And after that, I just insert 4 Spanish phrases into this table. I actually don't know Spanish, but I found this example from
yeah, man, pina colada, no need of Spanish for that one. Or probably pint also.
I see. Yeah. And then so here then I just same kind of a query, but I just have a order by clause, but some order by will have explicit collision to override the column collision. So the first one, there is no explicit collision specified. So well, YSQL is going to use the collision associated with the column, right? The column is SP. And then from this metadata table, we know the collision is ESUS. And then the rule, the sort order is this. The first, yeah. So this is the native order. If you don't, but then if you try to get the C, you want to see how this collision would, how this thing will be sorted.
So, but it's fascinating to see that in that first one, it's actually uppercase, lowercase insensitive, huh? It's
yeah, it is. I think it's like a, more like a dictionary order.
Dictionary order, yeah.
Yes. So whether it's uppercase, lowercase, that's secondary. You know, it's a more dictionary order.
Yeah.
But if we use an explicit collision clause, so in this case, Postgres or YSQL will use the more explicit one, because it will consider this one has it's stronger, so it has stronger strengths relative to the implicit one, and then it's going to use this, do the byte-wise comparison, and we can see that in byte-wise comparison, uppercase comes first, right?
Yeah, and in both cases, the N with the accent on stop sorts after the regular N, right? Like the piña comes after. Okay, got it. Okay.
Yeah. And then finally, this is the traditional libc UTF-8. So we have ICU. So by default, if you don't specify any collision clause, it's using ICU. But under libc, we can see it's this order. And in fact, all three are different. So
all three are different. And the N with the thing on top is before the regular N in this case. Yeah.
Yes. Yeah. So that in UTF-8, they sort things, really sort things differently.
Yeah.
And then next, I'll just show the platform dependency here.
All right. So this was on a Mac, everything we tried. Now you're going to run it on a Linux, I guess.
Yeah, I'm going to run on the same program. I'm going to just run here. This is on my Linux. It's a CentOS 7 machine.
Got it.
Yeah. So we get the same thing. The native order.
Yeah.
Will be identical. So here, this is the libc, libICU.
ICU, yeah, ICU. Yeah.
So as we can see, these two, they sort things the same.
Yeah.
Just from this example, at least for this example, libICU is a cross-platform, independent.
Yeah.
And then for libc is also independent, because they just do byte-wise comparison. So these two are still the same, right? But the difference is comes with UTF-8. This is Linux UTF-8. Compare with this one.
Yep, it's different, right? Yeah.
It is. So it looks like here the uppercase sort of intermixed. Here the uppercase is comes first.
Yep, and the space, everything is different. Yeah.
So we know that that's why libc, ENUS coming from libc, we have a platform difference. But I don't want to say which one is more correct, but it's a factor that we just have to we inherit from Postgres and also from the.
So one question, Minghui, from Jim, which is how can we show the current collation in YSQL? How can you see that?
It's a column collation, so you basically have to describe the table, like here, right? I describe
the /D shows it and the collation column.
Yes, but there is a second, I guess, a related question is what is the database collation, right? That's so sort of if we don't have a table, the database has a collation. So that is our database is Yugabyte database. We only support a C collation. So right now, database collation has to be C collation.
Got it.
And then yeah, so that, I guess.
But that's probably okay because you can override it at the column level, right? Like
yes,
sometimes,
at column level,
because it doesn't matter for,
yes. Yes.
Got it. Makes sense. Okay.
So I'm going to give another demo for the character C type case, right? So this is the second example. So let's look at this example, right? So this example, I'm going to show that whether this n with this thing on top, whether it's categorized as a printable letter or non-printable, it depends on the collation, right? So this collate should actually be called a C type, but in Postgres, it's folded under the same word. So collation C is it says this string is categorized with collation C, and under collation C, as we can see, this letter is not printable. Yep. This letter is not printable. So this is a regular expression function. It says I'm going to replace any non-printable letter with X, and we see that it is this letter gets replaced, right? And but in both UTF-8 and Unicode libICU collation, this character is considered printable. So that's why nothing is, every letter is printable here.
Yeah, got it. Makes sense. Makes sense. Okay, so we have about like a couple of minutes left, right? So maybe a couple of questions. What are the things that we don't support, and right, and what are the things we do? Yeah, I think maybe this is this would be good to talk about.
So yeah, this will be the second to last slide. So here, if you are familiar with Postgres, and if you have used collation, I guess if you have worked database for a long time, you sooner or later you hit this collation issue. Then you're going to realize that YSQL has very high feature compatibility with Postgres, right? So this slide has a lot of bullets on it, and then the list can go on. But the point I want to make is for the part that unless we explicitly say this YSQL restriction, for the most part, we are not just like Postgres. YSQL is Postgres.
Yeah.
So it's very seamless. If you're familiar with Postgres, you have no problem use it in YSQL.
Got it. So what works differently, I guess, would be the question then. Yeah.
Yes. And then as the developer who did this project, these are all the restrictions that I'm aware of. First is we haven't changed the database collation. So database still has a C collation because C collation, as I said, is the fastest. Speed-wise, it is the fastest. And secondly, we don't promote libc collation, and then this makes it inside libc. There's only like C or POSIX, only a few. So that makes creating database with a non-C collation less useful. Even Postgres, that you cannot create a libICU collation with a database. So I'm not sure how about the Postgres 14, but as far as I know, Postgres 13, you cannot create a database with ICU collation. That is still not implemented. So,
got it. So I think the way to summarize some of this is to say, we've as Postgres was evolving, they had added a lot of features, but now we kind of know the stable usage patterns, and we are adopting those into YSQL, right?
Yeah. We are adopting. Postgres might have realized that they made some mistake, like the last one, pattern matching ops. In my opinion, it's a workaround. When Postgres also did the collation support in stages, so they first had database collation, no column collation. But to work around the fact that did not column collation support, they provided this text pattern ops as a workaround. But now they have column collation. You can just say collation C. It will be a better way to do the same thing. So this thing, I think it should be deprecated at some point. Right, and then the third collision restriction, column collision cannot be altered. This is, of course, it would be better to allow that. However, YSQL today is in a bigger picture. Like when that, we don't support many like a column alter, because once you change the column type, for example, then most of the index you already built will have to be re-indexed.
Correct. And in a scalable database, that is a problem, right? Yeah, I think we support alter columns for compatible castable columns, right? Not
yes,
for
yeah. So for mostly we don't support, but in Postgres they have a statement like re-index. We haven't implemented that yet. So the re-index is not a supported feature yet. But if one day we do support a re-index, then of course we can come back, take care of this as in a bigger picture.
Fantastic.
Right.
And awesome. Thanks a lot, Minghui. This was fantastic. Yeah, really like learned a thing or two myself. Hopefully it was fun for all of the folks listening as well. So folks, join us next week, same time, same place. There's going to be another topic that's an interesting deep dive. You can continue asking us questions. Just join our Slack, yugabyte.com/Slack, and keep the conversation going. Thanks, everybody.
Yeah, thank you all for being here.